So this is piecewise functioning, and basically you're looking at all the different functions with limits. If you've done any of the marble slides on Desmos, it's pretty much the same thing. It's that you have a typical function and then there's a limit to it. So like the first function listed here as a given is a linear function. But the limit is the x values have to be less than or equal to -6. So therefore, we're looking at -5 and lower, so all the way to -infinity. Keep in mind that is before you do the math of subtracting 8 and taking the absolute value, because we're only talking about the x values. We're not talking about the output of the function. So when you're looking at this one, if the number is less than -6 or equal to -6, then you would choose this function and process the x term, or I guess in this case, the a term. So if you're looking at number 1, it says a of 8. Well, 8 is not less than or equal to -6, so we wouldn't use this x minus 8, the absolute value of x minus 8 function. Okay, so the next one is a quadratic. Okay, and so that's going to be applicable if your x value is greater than -6, but less than or equal to 1. And again, the first one is a of 8. That's not going to apply either. So we're going to move on. If x is greater than 1, then we're going to use this next linear function. It's a negative linear function. So a is 8. A of 8. 8 is greater than 1. So we're going to plop, and that's a nice term, plop, and we're going to place and insert, or substitute, I guess is the correct word, the 8 in for x here. So we're going to use -4 times 8 plus 7. And we'll get -32 plus 7 is -25. And we're only doing that for just one value right now because that's what this is asking of us. We'll get to graphing more of it later down the road here. So next, we're going to find a of 1. And 1 is going to fall into the second function, which is the quadratic function, because that is greater than -6, but less than or equal to 1. So we would put 2 times 1 minus 1 squared, which would be 2 minus 1, which equals 1. Okay, and then here we have a of -7. -7 falls into the first function because it's less than or equal to -6. So -7 minus 8 equals -15. But then we can't forget the last step where we have to take the absolute value. So we're going to end up with a positive 15. All right, let's move on down to this next one here. We're going to start graphing each function, and you're going to need to create your own table of values. And you have to make sure you use x values that fall into the definition of each function. So we'll start with 0. That's a favorite. -1 sounds good. -2, -3. Those all fit the definition of the first one. And then for the next one, we'd start with actually 1, because it includes 1, so might as well, 2, 3, etc. So of course, when we use 0, we're going to get -2, because that's going to be our y-intercept. 0, -2, that's definitely a good spot. And then -1, we stick in there. We get -5 minus 2 is -7. 2, 3, 4, 5, 6, 7, and over. And then it's going to fall off the graph. So I mean, is this where we're going to start as our y-intercept and just graph it down? No, that's actually, oops, I missed, sorry. That's actually not going to be sufficient, because what's happening is it's only when it's less than 1. So positive 99, well, 0.99 for an x value has to be accounted for. It gets graphed. And what about positive 0.637? All the values between 0 and 1 still have to be graphed. So it just doesn't include 1, but it includes all the points between 0 and 1. So we're going to graph 1 when x is 1, but we're going to have an open circle. So if you were to stick 1 into the function, you'd get 5 minus 2, which would be, sorry, that's not correct. I graphed it. You would get positive 3. And so you still need to account for positive 3 and graph it like that. That's kind of sloppy, but you get the idea. Okay? So you still would graph it all the way up to 1, just not including 1. That's your open circle. Open circle does not include closed circle includes. And I was telling a student the other day, I think of a closed circle like a fist, where I grab it, I'm holding it, it includes it, I've got it in my hand, I've grabbed a hold of it. So open circle means I've let it go, it does not include it, I don't have it. Closed circle means it's included. All right, so you can see here 0 is 0, -1, -7, and then it fell off and I really didn't need these other values. Positive 1, we included it in this first function to find its location, but it's an open circle because the y value is not going to be outputted into this function, from this function. However, when we go to the next function, 1 is included, so we want to also stick 1 in here for x. 1 minus 7 is -6. So we're going to go to positive 1, go down to -6, but this time we're going to color it in because it is included. Now we can do 2 is -5, 3 is -4, and we know that the slope is 1 anyway, so we know it's just climbing by 1s. I need to move a menu here. So on and so forth, it goes off the graph. All right, so let's talk about the domain and the range of this. The only place where there might not be an x value would be when x is equal to 1, because you see an open circle here. However, 1 is included in the other function. If the other function was just x is greater than 1, and the first function is x is less than 1, you would have two open circles, and you'd have to account for a domain that does not include 1. However, that's not the case here because x is greater or equal to 1. So there is no x value that's not going to give us an output. So the domain is all real numbers. All right, well, what about the range? Well, the range is basically double covered between -7 and +3. From y is -7 to, you have double y outputs. And remember, the definition of a function says double outputs is fine. It's just the double inputs you can't have. So these are proper functions. But when you're thinking about range, you don't have to account for the fact that there's double outputs. You just have to know if there are places where there are no outputs. And there aren't any. There's going to be basically from -infinity to +infinity, there will be y values. So that is also going to be all real numbers.